So let's come back to the binary file processor class that we created earlier in the course, and we'll come down and remove all of this code from the process method. This code is currently loading the entire file into memory. In the new version of this process method, we're going to use file stream instances to read and write individual bytes incrementally, rather than loading the entire file into memory. So let's start off by creating a new instance of the file stream options class that we saw earlier in this module, and we'll specify the mode as filemode.open. We'll create an instance of the input file stream that we want to use, and rather than creating this manually, we're instead going to use the static open method on the file class. There's a number of overloads of this open method. We're going to use this version, which takes a path to the input file that we want to open, and also a file streams options instance. Rather than creating a new file stream instance directly here, we're instead going to call the static create method on the file class. And as a parameter to this create method, we'll specify the output file path property. So now we have a file stream instance to read bytes from the input file, and a file stream instance to write bytes to the output file. I'm going to start off here by defining a constant called endOfStream with a value of -1. We'll use this in just a moment. Recall in the previous implementation, what we want to do is find the largest byte in the input file and append it to the output file. So we need a variable to hold the current largest byte that we found. Notice that this is an int. I'll come back to this in just a moment. And we're going to start off by reading the current byte from the input file stream by calling the readByte method. The return type of this readByte method is an int. It will return -1 if we're at the end of the file stream, or in other words, we've finished processing the input data. Because it can return -1, the return type is an int and not a byte. So now we can use a while loop to keep reading bytes from the input file so long as the readByte method doesn't return -1, which is why I created this constant here, just to improve the readability of this while loop. So at this point we've already read the first byte from the input file, which means we can write it to the output file. So we can use the output file streams writeByte method to do this. As a parameter to this writeByte method, we need to specify a value as a byte. So we can't just say current byte. We need to cast the int to a byte. We can now say if the current byte is larger than the largest byte that we found so far, update the value of the largest byte variable. We can now go and attempt to read the next byte from the input file, once again using the readByte method. Once the while loop finishes executing, we can go and append the largest byte to the output file, once again using the writeByte method and casting the largest byte int to a byte. Let's go and run this updated version. And this time we'll go and copy data4.data and paste it into the input directory here. That's the file processed, and we can see it in the complete directory here. What we're going to do is copy this file name, including the random GUID, and head to PowerShell. And as we did in the previous module, we'll use PowerShell's format-hex and paste in the completed file name. And just as we saw with the previous module, we have the original 4 bytes, followed by this largest extra byte at the end, FF. If you're just working with raw binary data at the byte level, then you may be happy sticking with file streams. If, however, you're reading and writing .NET data types to binary files, you can make use of the binary reader and binary writer classes to help you out. Let's take a look at this next.